Welcome everyone to the study guide review video for the 8th grade Unit 8 test on square roots, cube roots, Pythagorean theorem, and irrational numbers. Alright, so during the test you're going to take it on Desmos just in getting us prepared for taking the MCAS, right? So you're going to take it on the computer and then you're going to have scratch paper. I have this over here on the side to sort of demonstrate some of the work you could use, stuff you could do with your scratch paper. Okay. Cool. So question 1, select all of the numbers that are solutions to x to the third power equals 8. Third power equals 8. That means x times x times x equals 8. So we're looking for what number times itself is equal to 8. We can figure that out by taking the cube root of 8, right, if we had a calculator. Here the calculator function is disabled. You shouldn't use a calculator for this because this is one of the cube roots that I do want you to know. So the cube root of 8 is one of the right answers to this question. And then the other answer is 2 because 2 times 2 is 4 and 4 times 2 is 8. So the cube root of 8 is equal to 2. Okay, this is different than the square root of 8, different than 8 to the third power, which would be 8 times 8 times 8, which is a big number. It's 526, I think. Maybe 524. That's from memory. And then it's also not 8 divided by 3. All right, so just those. Cool. Question 2, this is pretty similar. Which value is an exact length of a square with an area of 12? So we have our square. It has an area of 12. So what is the side length? The side length is going to be the square root of 12. It's not 6. If the side length was 6, you would have an area of 36. Yeah. And if you had a side length of 3, you'd have an area of 9 square units. So take the square root of the area to get the side length. All right. Hopefully those questions feel good. Question 3, select all the right triangles. Okay. So for this, we are using the Pythagorean theorem, or really we're using the converse of the Pythagorean theorem. So we're saying if, right, this converse says if a squared plus b squared equals c squared, then it's a right triangle. So you can use your calculator for sure for this. You probably don't have to write all of them down, but I'll just keep track at least for the beginning. So for A, we have that the legs are the square root of 4 and the square root of 6, and the hypotenuse is the square root of 10. So we substitute those into the Pythagorean theorem, and we get the square root of 4 squared is 4, the square root of 6 squared is 6, and the square root of 10 squared is 10. So we get 10 equals 10, and that is correct. So A is going to be one of our right triangles. Okay, do the same thing for B. So this one, the longest one, is whatever we're going to call C. So the longest one, we have the square root of 16. So square root of 9 squared plus the square root of 8 squared equals square root of 16 squared. 9 plus 8 equals 16. You get 17 is equal to 16, and that is not true. All right, I am allowing you to use a calculator for this part, so just to show you how you could do it here, you could do the square root of 9 squared plus the square root of 8 squared, and then you get that's equal to 17, and then you could check that the square root of 16 squared, of course, is 16, so we don't get the same thing. All right, for C, if this were a right triangle, the square root of 13 would be the hypotenuse, so that's going to be in the C spot. Then we have 2 squared plus 3 squared, and let's see if that's equal to the square root of 13 squared. 2 squared is 4, 3 squared is 9, and the square root of 13 squared is 13. So we get 13 equals 13. That is true, so that's a right triangle. Okay, continuing on. D, 5 squared plus 12 squared equals 13 squared. 5 squared is 25. 12 squared is 144. And 13 squared is 169. Again, you could use a calculator for that. Then we do 25 plus 144, and you will get 169. So 169 equals 169, so that one is also going to be a right triangle. And then briefly, we can just test this out on the calculator, make sure we did the math right. 169, 169. So that's the true equation, so that is a right triangle. Okay, last one, just do quickly. We have 8 squared plus 9 squared, and then let's do 12 squared, and we get not the same number, 145 versus 144, so E is not a right triangle. Great, okay, so again, this scratch paper, like, you wouldn't have to write it down, but I do encourage you to write it down to keep track of your work, because it will help you catch your mistakes and take your time. So, scratch paper, good, use it. All right, question 4, select all of the irrational numbers. So, irrational numbers are numbers that go on with no repeating pattern, go on forever with no repeating pattern. So, the classic example of an irrational number is pi, 3.14159265535, etc., but it never ends, and there's no sort of repeating pattern, like 1/3, that 0.3 repeating, that is rational, okay, because we have this repeating pattern, but pi is irrational. Okay, I mean, I guess I'm saying that's the reason, but that's not really the reason. It's more of like a, yeah, I mean, really the reason, the definition of the word rational is we have ratio in it, which is like a fraction. So rational numbers can be written as fractions of whole numbers or ratios of whole numbers, where rational numbers can't. Okay, some of that was kind of a side note. What really matters here is square roots and cube roots of a lot of non-perfect squares and perfect cubes are irrational. So, okay, pi plus 1, that's irrational because pi goes on forever with no repeating pattern, and pi plus 1 is just 4.14159265535, etc. Goes on forever, no repeating pattern. The square root of 16, however, that's a nice number. That's 4. 4 times 4 is 16. So that is rational, so it's not one of our answers. The square root of 30, however, that is not rational. The square root of 30 is not a perfect square. It falls in between the square root of 36 and the square root of 25. So it's about 5 point something, about 5.5. But that is going to be irrational. So when we have those roots of our non-perfect squares. Okay. Then we have the cube root of 64. So is there a number times itself that equals 64? Yes, the cube root of 64 is 4. 4 times 4 is 16, and then 16 times 4 is 64. Oh, whoops, never mind. So that is rational, just a nice number, integer. So that's not going to be one of our answers. The square root of 12, however, is irrational. It's in between the square root, or sorry, did I say square root before? Cube root, this is the cube root. It's in between the cube root of 8, which is equal to 2, and the cube root of 27, which is equal to 3. Okay, and then the number 8 is just rational. Integers, nice whole numbers, are always rational. So irrational numbers, you can't estimate with a fraction. The reason we kind of create these symbols, like the symbol for pi and the symbol for the square root of 30, is because there's no other way to exactly write these numbers, right? Because in their decimal form, they go on forever with no repeating pattern. So the only way to write them exactly is using these kind of special symbols. Okay, cool. Question 5. What is the exact length of the unlabeled side of this right triangle? Use the sketch tool if it helps with your thinking. Yeah. Okay, So we can just use our scratch paper. We have a right triangle. This is sort of a basic application of the Pythagorean theorem. We have our legs. We have A. We have B. Doesn't matter which you call which. C, the hypotenuse, is what we're looking for. So we can take C squared plus 4 squared. And we'll get 36 plus 16. 36 plus 15 is 16 is 52. So C squared equals 52. So C is going to equal to the square root of 52. All right, question 6.1, which means it's a two-part question. Drag the movable points to the correct position on the number line. Okay. So here, let's first look for some clear, easy ones that we know. Okay, so I see the square root of 16, and I know that the square root of 16 is equal to 4, because 4 times 4 is 16. So I'm going to drag that right there. Okay, I also know that the square root of 1 is 1, because 1 times 1 is 1. So I'm going to drag that there. And the last perfect one that I know is that the cube root of 27 is equal to 3. 3 times 3 is 9, and 9 times 3 is 27. All right, so I move those. And then these other two, they're not going to be, these are irrational numbers, the last two. So we're not going to be able to get it exactly right. We're just going to do our good estimate. Okay, so for this, I'm going to think about the square root of 10. What two perfect squares does that fall in between? So I know what the square root of 9 is. The square root of 9 is 3. And I know what the square root of 16 is. That's 4. The square root of 10 is going to have to be in between the square root of 9 and the square root of 16 then, so it's in between 3 and 4. It's just square root of 10 is just slightly bigger than the square root of 9. So, all right, there we go. And then last but not least, we have the cube root of 8. One of the same, last but not, okay. And then finally we have the cube root of 9. That's going to be in between the cube root of 8 and the cube root of 27. So the cube root of 8 is 2, and the cube root of 27 is 3. So the cube root of 9 is going to be in between 2 and 3, and it's going to be really close to 2, slightly bigger than 2. So it's like slightly to the right of 2. Great. Cool. All right, 6.2. So this is related to what we just did. Chloe plotted the square root of 1 on the number line at a half. Explain how you know this cannot be the correct position for the square root of 1. Okay, so we're going to prove, like, why is this 1/2 wrong? So what we can do is we can say 1/2 times 1/2 is going to be 1/4. So thus, right, it would be like the cube root of 1/4 is equal to a half, not the cube root of 1, the square root of 1. There's like other ways. Let's see, how do they explain it? Yeah, that's how they explain it. Yep, so the square root of 1 cannot equal 1/2 because 1/2 squared is 1/4, not 1. Yeah, I mean, there's other sort of versions that you could give, but that's the idea. So, you know, you could write it like I did, or you could type that. I think I'll just save time and not type it again. But yeah, just kind of explaining that's wrong, right? People would make this mistake because they think the square root is like just divide by 2, right? So they're dividing 1 by 2, but that's not what it means. Great. All right, question 7. Exactly how long is the line segment between the points 1, 3, and 5, negative 2? Use the sketch tool if it helps with your thinking. So to find the distance, we can create a right triangle, and then we just have to figure out what are these vertical and horizontal distances, like the height or the base of my right triangle, or the 2 legs. So for that, we can see that we have the point 1, 3, and the point negative 5, negative 2. So if we're trying to find that vertical distance, we're paying attention to the y values, right, for our vertical distance. Right, we're going from up here, positive 3, down to negative 2. So, like, what is the change between negative 2 and positive 3? That's a change of 5. Right, this is up here at 3, and this is at negative 2. The distance between that is 5. You could subtract, theoretically, to figure that out. 3 minus negative 2 is 5. Another option, which I'll talk about in a second, is you could use graph paper and graph these points better in a way that's like more clear with the grid marks. So I'll do that later. But next, we'll talk about the other leg, the horizontal change. The horizontal, we're going to focus on the x-coordinates, right? Because the x-coordinates are telling me my horizontal. And here I'm going between positive 1 and negative 5. So that's a change of 6. Again, you could subtract that to figure that out. Okay, and then once you've done that, that's sort of the hard work. Now we use the Pythagorean theorem. We're trying to find the hypotenuse, C. That's the diagonal. So we do 5 squared plus 6 squared equals C squared. It's 25 plus 36, which is 61. So C is the square root of 61. Okay, and then again, just sort of briefly what I was saying is you could also like create a grid on graph paper. Like this is a totally fine idea, particularly on the MCAS, right? If you're stuck on a question like this, you can just draw it. So we have the point 1, 3, right? That's 3, this is 1, and then 1, 2, 3, 4, 5, negative 2. You could create it on a grid and then just count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Right, so that works too. Awesome. Okay, question 8.1. Here we are applying the Pythagorean theorem to solve a real-world question, in this case about ice cream. Fun. An ice cream cone has a 10 centimeter diameter and a slant height of 13. What is the height of the cone? Okay, so here we have to know a little bit about circles, and we will, after the MCAS, get into cones in some more detail. But key thing we need to know in order to answer this question from 7th grade is that when the diameter is 10, the radius is half of the diameter. So we have this cone, but we really are getting a right triangle from it, which is pretty fun. So if the diameter is 10, the radius is 5 centimeters. They give us the slant height, which is 13 centimeters. And then we basically have a right triangle where one leg is 5, the hypotenuse is 13, and we're trying to find the other leg, which we can call A. And then we use the Pythagorean theorem. So I'm going to substitute in 5 for B and 13 for C. 5 could go in for A or B, but it does matter, of course, that the hypotenuse is C. So we get a squared plus 25 equals 169. Then we essentially solve this equation, so we subtract them. We get that a squared is equal to 144. So thus a is the square root of 144, which is 12. So this cone is 12 centimeters tall. So I have the work on my scratch paper, but now they want us to explain or show the work, so we'll briefly summarize it. So we can write something like this. The radius had to be 5 centimeters because it's always half the diameter. From there we can get a right triangle with a leg of 5 centimeters and a hypotenuse of 13 centimeters, and we can use the Pythagorean theorem to solve for the height. Cool. All right, last question is actually not particularly related to what we've mainly been doing, but I did mention that we're going to talk about cones in a little bit more detail, also cylinders and spheres after the MCAS. And one thing that we'll learn is how to find the volume of a cone. So since you might see it on the MCAS, we're just going to really briefly see how to do this. You're given a formula, so as long as you know how to use a formula, it's really quite straightforward. We want to find the volume of the cone. We have the formula volume is equal to 1/3 times pi times the radius squared. So we just found in the last question that the radius was 5 and that the height was 12. So we have 5 squared plus 12. Okay, you can simplify that lots more, and we'll talk about that more again after the MCAS. But for the moment, just put this entire thing into your calculator and you get the answer. Okay, it's going to be a rounded answer because we have pi involved, and so we're rounding there. But yeah, that's all it is. So we just need to be able to substitute into the equation, and I just want you to be able to see that and know that you can figure out a question like that. So, and then for show or explain the work, I'll just type in exactly what I typed into the calculator. Great. All right, awesome work, everyone. Good job. Good luck on the test.